We're going to look at number 41 here. And this, if you draw a picture here, and we have triangle ABC, so I'm going to draw a triangle and try and draw this somewhat to scale. So angle A is 25 degrees. Little side A is 25, so this side would be 25. And I'm going to put angle C down here, which makes little side C 32. I'm going to call this angle B on the top. So as you can see, this is a side-side angle situation, which means we need to use the flow chart to determine how many triangles are involved here, because it's possible that no triangle could be formed with this given information, only one triangle, or two triangles. So if you go to the flow chart, okay, and it's an acute angle, okay, the first thing it says, now on the flow chart it says compare A to B for an acute. Well, we're given side A and side C, so we're going to compare A to C. And if you notice, A was 25, C was 32, so A is less than C. Okay, and then we have to compare A to C times the sine of A. So A is, little side A is 25. C times the sine of A is 32 times sine 25. And if I do that, I have 25 for A, and if I do 32 times sine 25 on the calculator, I get 13.5, and so that's bigger. So A is bigger than C sine of A, and you follow the flow chart. If you're following along with me, that is, two triangles can be formed. Okay, so the one I have drawn right here, this one right here, is one way to draw the triangle. The other way to draw the triangle is this, and I'm going to draw it over here. So this I'm going to call triangle number 1. Okay, the other way we could do is we could take this side right here and swing this side back, okay, or swing angle C back, and we'd have this triangle formed. So this would still be 25 at angle A. Side A would still be 25. I didn't draw that real great, but this is angle B. This is angle C. So angle C becomes an obtuse angle in this other triangle, and this side would be 32. Okay, so we still have the given information, and we'll talk about how to find the answers or solve that second triangle here in a little bit. But let's first go through the normal solutions in this first triangle, triangle number 1. So we're going to go sine of 25 degrees over little side A, which is 25, equals sine C over 32. And if we cross multiply like we've done on the other problem, sine C will equal 32 times sine 25 divided by 25. So the sine of C is about, and if we go to like 4 decimal places there, sine of C is about 0.5410. If you do that calculator work to find C, we do inverse sine of 0.5410. So angle C is about 32.7 degrees. Okay, and again we're solving it. So that means this right here, this angle right there, is 32.7 degrees. now I could find angle B by taking, because that's my third angle in the triangle, I could do 180 minus my angle A, which is 25, minus the 32.7 angle C that I just found. So angle B is about 122.3 degrees to the nearest tenth. And then I would have to do, to find little side B, which would be this angle down, or this side down here, I would do another law of sines. So sine 25 over 25 equals sine 122.3 all over little b. So little b would equal 25 times the sine of 122.3 going that way, divide by sine 25, and b should be about 50.0. Okay, now that's the answers for triangle number 1. These three right here. In triangle number 2, all we've done is swung this side back, and what that's done is made B a very small angle and C an obtuse angle. So that angle C in the second triangle, the obtuse angle right here in this triangle is always the supplement of what angle C was in the first triangle. So angle C was 32.7, so angle C in this triangle is supplementary angles add up to 180, is minus, we take 180 and subtract 32.7. So angle C, that obtuse angle, is going to be 147.3 degrees. The reason for that is because that sine, the sine of 147.3 is the same as the sine of 32.7. It's a first quadrant angle and a second quadrant angle. But you just need to remember that that angle in the other triangle is always the supplement. These two angles are supplementary. Then I have to go through and I have to find angle B by taking my 180 minus my 25 degree angle, and then I'm running out of room here, but minus 147.3. So angle B in this second triangle, notice it's a really small angle, is only 7.7 degrees when I do the subtraction. And then I would have to do a law of sines, so the sine 25 over 25 equals sine of 7.7, so that angle B that we just found over little b. And if I go through and cross multiply, I should get, cross multiply and divide, I should get B equals 7.9. So there's two sets of answers. These are triangle number 2 answers, where C is an obtuse, and then these three right here are triangle number 1 answers. That only occurs when you follow that flow chart and you come up with 2 triangles.